Meet Joey. Joey is a tech-loving guy and he loves to have coffee. Joey has a coffee shop nearby his home, which he often visits. This is certainly Joey's favorite coffee shop. When Joey orders coffee, the waiter always gets him a new one. Be it the first time, the second, or the third. Once Joey is done with his coffee, he returns back to his home, where he takes some rest. Well, this is a typical day in Joey's life. To understand the Singleton Design Pattern, there are two major things that we need to focus from his life. First is his home. Second, well, you guessed it right, it's his coffee. Let us try to identify which of these entities are singletons. To identify the singletons, we first need to understand what it actually means. The Wikipedia says that the Singleton pattern is a software design pattern that restricts the instantiation of a class to one single instance. This term actually comes from the mathematical concept of a singleton set, which represents a set with only one element. Now that we know what a singleton is, let's try to get back and classify these objects as singleton or non-singleton. If you recall, the coffee is always a new one, whenever Joey requests, so in software paradigm, we are creating a new instance of the coffee class for each request, which is in contrast to the definition of a singleton, and hence, coffee is not a singleton. On the other hand, Joey's home, whether he comes out of it to get a coffee or goes back to his home, or whether he goes to college and comes back, it's always the same home. For each request for the home class, we are always returning the same instance and hence the home is a singleton. Now let us try to model the singleton home object in a popular programming language, Java. First of all, we create a static instance of the home class which we will return for each request, and then we create a constructor. Note that the constructor is private. This is done in order to ensure that no other object has the access to initialize this home class. Now let us come to the heart of this class, which is the getInstance method. On each request, this method first checks if the static home instance is initialized or not. If it is not initialized, we create a new home instance and return it. If the instance is already initialized, we simply return the cached object. This process of initializing a resource as per need is called lazy initialization. The getInstance method also provides a global point of access to this singleton home resource. As it has public accessibility, it can be called from anywhere in your software. So this is how this code is ensuring that the home class is modeled as a singleton.